There we go. And now I'm back live. Give people an opportunity to leave that comment in the chat. That'd be wonderful. Oh, my goodness. It's already Thursday. See, I left the thing in the door.
Oh my God, thank you very much.
Yeah.
You got lost.
I'm sorry.
It's okay.
From where?
Huh?
From where?
Well, first we were in the library, then we were walking, then we bumped into a wall, and then we were like, what?
That's a cool story.
Yeah.
You tell another one?
It always smells like coffee in here. It's so wonderful.
All right. Anyway, where was I? I lost my complete train of thought now.
I'm so sorry.
That's okay. So, goal for today. At noon, we are going to have one of those joyous intervention periods one more time. I'll talk about that when the time comes. I have a Google Slides set up to send to you guys that you are going to work on for that intervention period. Keep in mind that the assignment that I give you for the intervention period today, I'm also going to have you work on Monday as well. So don't feel like you have to finish it today. I'm not actually going to make it due until Tuesday. So you do have all that extra time to kind of get it done. That whole intervention period, remediation, blah, 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 blah junk. Anyway, as for today, I would like to continue with what we were doing with solving rational functions. I do have some things planned for that. Just be aware, as a reminder, what is due for teachers on Monday? Yay. I'm trying to update as much as humanly possible. I have plans moving forward in terms of assessments that I'm going to be giving you. I'm putting the finishing touches on an edge elastic assessment in regards to rational functions. And I will have a short project as well, but I'm going to talk more about that short project next week. Today, my goal is just knock out that intervention period garbage crap. And then we'll do that on Monday as well. And then I will talk about that edge elastic major and project next week. But we'll get that thing done. But again, please be aware of the schedule. I'm going to try to mark these off. I believe that these are like regular exams. But then before that is senior exams, as we've talked about. This time is going to go by so stinking fast. Like you think about it, on Monday, you'll already be halfway done with the month. Think about that.
Thank God.
And then at the end of the month, you get 5 days off.
Yeah, bro.
Yeah. It's-
5-day weekend.
I'm just saying, it's going to fly by. Yes. It can be. So I'm going to take care of two things at once. Number one, you need to make sure, those of you in the classroom here, I need you to dig out this worksheet from the other day. This worksheet is entitled 8-6 Practice. I believe I gave it to you on Tuesday. For those of you in the live chat, I posted the link to it, the PDF to it, into the stream the other day. I will copy and paste the link into the classroom stream. Won't let me do that there, so I'll have to do it here. There we go. But I will copy and paste that link for you guys. Where are you? Oh, that's the wrong. No, that is the right class. Okay. There's the PDF. It won't let me. Goodness, why won't it let me? Oh, well, it won't let me copy and paste the link. I'll have to figure out another way to do that. Yes. Yeah. Anyone need a copy of this before we move forward? The 8-6 Practice. I do have a few extra copies if need be. Okay. And with that, ladies and gentlemen, have that worksheet ready to go. And if you do not already have them out, I'm going to need those notebooks out and open. Yes. Excellent. Okay. Moving over here. See if I can get that thing posted in the chat real quick. Let me see. Copy link. Click this. Let's see here. Post. Boom. There we go. So for those of you in the live stream, I just posted the link to the PDF just in case you were not able to get it or get to it, I should say. Let me flip my camera over. Here we go. Click, click. Here we go. Yeah. So the other day, we were solving these rational functions. I taught you 2 strategies for solving these particular functions. And these 2 strategies I would like to get a little bit of practice with today. So I am going to call this solving rationals continued. Yes. Yeah, the one that you guys were looking for. Yeah, go over here. That's what I was passing out before. But the first problem I would like you guys to copy down is actually problem number 2 off of that worksheet. Problem number 2. I am going to be jumping to different problems on this particular worksheet today. And because you have that copy of it, you can see it a little bit better. But I would like to definitely do this particular problem first, number 2. It appears at first glance to be a very simple problem. It's just a few x's floating around, 1s and 2s, small numbers. X over x minus 1 minus the whole number of 1 equals x over 2. Let me actually sharpen this. I have a colored pencil that I need sharpened. I'm going to use this thing today. Now, there are 2 strategies that I walked you guys through the other day. Here we go. Oh, that worked out great. There are 2 strategies that I walked you through the other day. Strategy number 1, find a common denominator, combine those fractions, and butterfly. That was strategy number 1, butterfly. Strategy number 2 is to multiply through everything and destroy the fractions. Regardless of which method you end up doing, you end up with the same answer. Now, in this particular problem, I'm thinking that I'm going to want to do strategy number 2. See, when you see these problems, sometimes it is in your best interest to do one strategy over the other. It depends. It really stinking depends. Yes, it does. Do you want to know the absolute 100% truth behind me saying strategy number 2 is probably better here? Because yesterday I did strategy number 1 with my other Algebra 2 class, and it took forever. I'm being completely honest. I looked at this problem yesterday and I thought to myself, let's do strategy number 1. And then I walked them through strategy number 1 and it took up almost 2 pages. And I'm like, not making that mistake again. Let's do it the shorter way. Let's do strategy number 2 where we destroy all the fractions. So the first thing I got to do when I want to do this strategy, if I want to destroy all my fractions, I have to look at all of the denominators. I have a denominator of x minus 1. I have a denominator of 2. And yes, this number, even though it doesn't visually have a denominator, you can put the denominator in there, put it over a 1. If I were to multiply this first fraction by x minus 1, it would destroy that fraction. But if I multiply that fraction by x minus 1, I have to multiply everything by x minus 1. If I were to multiply this fraction by 2, it would destroy that fraction. But again, I'd have to multiply everything by 2. This is how you make the determination as to what you should multiply by. Now, that middle number, that 1, that -1, technically, yes, it is a fraction, but since it's a whole number to start, I really don't have to worry about it. But what I'm going to do is I'm going to multiply everything by x minus 1 and by 2. Make it a little bit darker right there. Now, I'm going to use the colored pencil to kind of show what's going on here. But let's see what happens after I take that x minus 1 and that 2 on the far right. Let's see what happens after I take that and distribute it to all 3 terms. If I distribute it to the first fraction, who's in trouble?
Bro, I hope it's me. Bro, I literally hope it's me.
Mr. Vargas here. Hey. Yes. Okay, that probably won't be until tomorrow, though. Okay. Gotcha. Okay. Oh, gotcha. Yeah, I had written that time down actually, but then I okay. Got it. Okay. Sounds good. Bye-bye. It was me. I'm in trouble. No, I'm not. Yes, I am. You don't even know anymore.
I don't know anything. Everything's just freaking lie.
I'm sorry.
It's okay.
The cake is a lie.
Everything's cake, right?
No, it's a video game reference from a long time ago that you wouldn't get. Just saying. It was an obscure reference. Anyway, back to this.
And I was stating that everything is cake. That's my own reference.
Is it?
Yeah.
Okay. Well, watch what I'm going to do right here. Now, everything that I'm writing in red is what's been distributed to all 3 terms. I'm just doing this visually for this problem. You clearly do not have to do this for every single problem. Yeah, you don't have to do this for every problem. I'm just going to do it for this problem so you can visibly see what the heck is going on. But that x minus 1 and that times 2 has been distributed to all 3 fractions, as you can see right there. I wanted to put it in red so it was a little bit more visible. But when you distribute it to all 3 terms, watch what happens. If I have done this correctly, then all fractions should be destroyed. Yeah. In the first fraction, the x minus 1s clearly cancel each other out. In the second fraction, I didn't have to worry about anything canceling out because it was already a 1 in the denominator. But in the third fraction, the 2 cancels out. Again, not necessary for every problem. This is just giving a visual approximation as to what is happening. Make this a little bit more noticeable with this x right here. I'm crossing that one out. The what? I thought it was a question.
No, more just a statement.
Oh, my bad. Okay. In the first fraction, the only thing that's left over is a 2x. In the second fraction, I'm going to have to simplify that out a little bit in the second fraction. In the second fraction, yes, I'm going to have to distribute that 2. But notice right here, look where I'm pointing. Not only am I going to have to distribute a 2 into that second fraction, but I'm also going to have to distribute a negative sign. So please keep that in mind. I'm going to do that in the very next step. I'm going to distribute the 2 and that negative sign. So I'm going to get minus 2x plus 2. There we go. Equals. Now, in the last fraction, I am going to have to distribute that x. X squared minus x. let me just recap what the heck happened before we continue with this problem. And believe me, and actually I'll show you the work that I did yesterday with the other Algebra 2 class. I'll show you how long it took to actually do that problem. Now, we're not done yet with this problem, but we all already are much farther along than the other Algebra 2 class.
Wow.
Basically, you look at the denominators, you determine what you are going to multiply by in order to destroy all the fractions in one fell swoop. You proceed with multiplying through, which would destroy the fraction. Well, in the first fraction, the x minus 1s will cancel, leaving you with just an x times 2, which is what ends up happening along the left side right here. In the middle fraction, nothing cancels, it's just a minus 1, but you have to take that minus 1 and multiply it by everything in red right here, which ends up being minus 2x plus 2. And in that third fraction, multiplying through cancels out the 2's, but that red x minus 1 is still there, and you have to simplify it. Let me show you what they did yesterday. Hold on. Here we go. This is what they did yesterday. I'll move that paper, I'll come back. So yesterday we tried strategy number 1 here. Strategy number 1, this is yesterday. You can see the date at the top. That's May 12th. That's yesterday. We tried multiplying that minus 1 to get a common denominator. And then we got that common denominator. But then once we got that common denominator, then we had to proceed with the butterfly method. And then once we got to the butterfly method, then eventually we got down to this quadratic. It can be if you decide to take the long way. It doesn't have to be a nightmare. With this problem, I want you to notice that I have a quadratic. I have a quadratic. I'm going to have to solve a quadratic. If you notice where I'm pointing, that's the reason why I know I have a quadratic. Also make note, this doesn't always happen, but what happens right here?
I don't know.
Yeah, they do. They cancel out. It doesn't always happen like that, but it just so happened to happen there because, well, 2x minus 2x. Then I'm going to subtract the 2 over, and I end up with my full quadratic. That's what I now have to solve. Number 2 starts out as a bunch of unrelated fractions, and through using strategy number 2, you've turned it into a quadratic that is solvable. Not only solvable, you can factor that thing. Now, I'm not going to spend a long amount of time talking about how to factor that thing. I'm just going to go ahead and actually do that. You're going to get a little practice with that later. But this thing factors into x minus 2, x plus 1. Ultimately giving me my answers of x equals 2 and x equals negative 1. There's some feedback coming from outside. Did y'all hear that?
Yeah, I hear that.
That was weird. Anyway, back to this.
Ew, ew.
That's not feedback. That's a car alarm.
That's more of a robot.
Debatable. Anyway, answer me this. Looking back at the original problem written in black, there is only one number that you are not allowed to have as an answer. There is only one number that you are not allowed to have as an answer. And that answer is positive 1. You are not allowed to have positive 1 as an answer to this question. The reason being is because if you did end up with positive 1 as an answer, it would force this denominator to be 0. But thankfully, we did not get positive 1 as our answer. So both of those numbers work. Both of those numbers indeed end up working for this particular problem. I want you to try something here. I want you to try a short problem. I'm going to have it written down as well, but obviously you do have it on your worksheet. but I want you to try this one on your own for a little bit. I want you to try number 5. I want you to try number 5. Number 5 is a fairly straightforward problem, except it does have a twist ending. It does have a twist ending. So what I'm going to do is I'm going to write down number 5. And I would like you to try and solve it. Now, technically, you can use whichever strategy you want, but I am going to recommend that you use strategy number 2, where you multiply through and destroy all the fractions. So take a little bit of time right now. See if you can't get to the twist ending that number 5 has in store for you. And we'll reconvene in a short bit, maybe 2 or 3 minutes. Unfortunately, I do not. I think, yeah, I'd be able to give those, wouldn't I? They have like certain rules for like teachers, what they're allowed and not allowed to give out. Like we can't give out like aspirin or anything like that. But I think cough drops would be fine, right? Yeah, I don't have any though. The best I can offer is a Band-Aid.
If you go to the nurse, they send you home. Is it COVID? Huh? Do that. I can't.
No, I said do that.
Yeah.
Because they didn't one time they didn't send it.
Like, say you get a Band-Aid, like, because Jess went and they sent her home to get her get a COVID test.
No, just be like, I want to cough.
I'm hungry. Bro, Mr. Murphy, they gave me a chicken sandwich with barbecue sauce and cheddar cheese on it. It was so gross, Mr. Murphy.
They tried to put like the shredded cheese.
Like,
I didn't.
I could smell on the other side of the table. I didn't eat it because it was actually. I have a picture. Is it okay if I come show you what it looks
I
like?
have my own.
What happened to getting my problem done?
I'll get it done. Just not right now.
Psh.
It looks like somebody took a shit on it.
Wow, she used a bad word. It looks like somebody tried making a taco on top of like something, you know?
Yeah.
What?
So, no.
Why?
Because I have your homework done. I literally have it.
Take pictures
Yeah, I know.
and send it in. Yeah. The long story short of the entire year, I mean, is that obviously since September I've been lenient with the due dates, but obviously it comes at a price sometimes. But the price is not too steep. All right. If you're almost there, you might end up already seeing where this twist is going to take place. Well, let me get this problem started. What's really nice about this particular problem is the fact that the two fractions both have the same denominator already. So you don't have to make a decision as to what you're going to multiply by. You're just going to multiply by a y minus 5. You don't have to worry about the 1. Just worry about the y minus 5. If you multiply both sides of this equation by y minus 5. What ends up happening, and I'm going to do this kind of in the shorter way, the way that you would most likely do this when you were working it out yourselves. Yes, I'm going to distribute that to all three terms. In the first fraction, they cancel, leaving you with a 5. In the second fraction, they cancel, leaving you with a y. In the third fraction, nothing cancels, but it's minus 1 times y minus 5. I am going to have to take care of that. I am going to have to distribute. Make sure that y minus 5 was in parentheses. Now, since I am distributing this, yes, keep in mind, it is a negative 1 that's being distributed. So I end up with 5 equals y minus y plus 5. Oh, holy crap, I end up with 5 equals 5.
Holy.
What does that mean?
Holy.
What does it mean, though? Oh. See, typically you should be ending up with like the variable equals a number. X equals 5, X equals 2, Y equals 1, whatever, those kinds of things. But here, both my variables canceled. Now, something like this happened the other day. The other day, we did a problem like this, and we ended up with something like negative 12 equals 0. I'm fairly confident that that was the problem from the other day. Negative 12 equals 0. And it was a false statement. Okay. But the other day, we got negative 12 equals 0. It was a false statement, meaning there was no solution. But here, we end up with 5 equals 5, which is a true statement. So here's what you're going to write. You're going to write infinite solutions. Except ... Hold on a second. I'm trying to tell you that there are infinite solutions to this problem. Give me a number, any single digit number. 3. Let's go with 3. Watch what happens when I take 3 and I plug it into this problem right here. Watch what happens. If I take a 3 and plug this sucker in right here, 3 over 3 minus 5 minus 1. Here, I end up with the fraction negative 5 over 2. Over here, I end up with the fraction negative 3 over 2 minus 1. But minus 1, that would actually be minus 2 over 2. Yeah, that works. I get negative 5 over 2 on both sides. The 3 worked. Give me another number. Let's try 7. If I plugged in. Okay, all right. 5 over 2, 7 over 2 minus 1, which is actually minus 2 over 2, which gives you 5 over 2. It works. So you gave me a 3, it worked. You gave me a 7, it worked. There are infinite solutions to this problem, except for one number. Except for one number. Now, that is not the number. That is not the number. That is not the number. Except, I said that there are an infinite number of solutions. They gave me a 3, I plugged it in, it worked. They gave me a 7, I plugged it in, it worked. Every single number in existence will work. There are an infinite number of solutions, except for 5.
Why?
Very good question. Why can't 5 work? What happens when you plug 5 back into the original problem? What happens when you plug in 5? You get a 0 in the denominator. Can't do it. There are technically infinite solutions. The only exception is 5. Notice the symbol right here. Somebody actually asked me about that the other day. They had never seen that before. That just means not equals to.
Sorry, that's just funny that somebody didn't know that.
They asked, and I'm like, okay, so I explained it. It just means not equals to. Because they're like, what's with the equal sign with a line through it? I'm like,
That's embarrassing.
a little bit. But they asked, and I'm happy that they asked. That's all that matters. Okay. I'm going to give you a little bit of time right now to try 2 problems. And I'm going to suggest which strategy I want you to use on each. I'm going to have you do numbers 15 and number 8. Number 15 and number 8. And I'm going to split my page in half. You don't have to do that. You can do whatever you need to in your notes. But I'm going to have you do number 15 and number 8. Number 15, I would suggest using strategy number 2. That's the one that we've been using mostly this day, where you multiply through and destroy all the fractions. But then on number 8, I'm going to suggest that you use strategy number 1 for a couple reasons. On number 8, actually, you know what? I'll write it out and then I'll explain. It's easier if I have the visual. Strategy number 1 is where you combine fractions and then you butterfly. The reason why I'm suggesting strategy number 1 on number 8 is for this reason. If I were to multiply that second fraction by 2/2, I would be able to combine those 2 fractions and immediately transition to butterfly. I don't have to worry about it. It's automatically taken care of for me. That's what I'm going to suggest that you do. On number 8, multiply that middle fraction by 2/2. Combine those 2 fractions into 1. Then butterfly that thing out. And see what you can do with it.
Mr. Murphy,
Yes.
do you know what a juju on that?
I vaguely remember what you're talking about. I think that's a meme from like 10 years ago.
I'm so sorry.
But then again, on number 15, I would suggest that you use strategy number 2, simply because there are 2 denominators that are both the same, and you could multiply through and destroy all them in one shot. Now, I want you to take some time with this. I'm going to give you a little bit more extended time to knock out these 2 problems. And I'm telling you, I'm suggesting to you which strategies to use, simply because they may be easier because of what the problem is offering. Now, I will tell you, both of these problems will give you definitive answers, but make sure you double check to make sure that the answer is valid, where you, I can't plug that number back in, or I can plug that number back in.
I'm so sorry. I'm so
I don't know what that means.
Great. I gotta forget. Make sure the answer is valid. Yeah.
Okay, let's work on these 2 problems.
How long do you guys study before you punch somebody in the face?
I'm not sure. It depends. Who are you punching?
Depends.
Is it a teacher? Is it a student?
Student.
Oh, I don't know.
9 days. I'm just thinking. What would happen if we didn't have noses?
The human body eventually developed what is known as the nose, but other creatures during their developments developed other forms of breathing apparatus. For example, fish develop gills.
Voldemort developed nostrils. Why does Voldemort look the way he does?
Because it looked more like a snake.
Yeah, but why? Because Tom Riddle was hot. Then he turned into Voldemort, and then he turned ugly and didn't brush his teeth.
Because his outward appearance represented his inward heart.
Yeah, yes, I understand like the metaphor, and I understand that, but how he actually physically turned ugly.
Well, because his body died. His body was destroyed, and he was reincarnated. Don't you remember the first movie?
Yes.
The first movie where he's on the back of the dude's head?
Yes.
Yeah, he was reincarnated as a spirit since this Horcrux still existed.
So he just, and then in Goblet of Fire when there was a baby
I-
Voldemort.
Well, yes, but again, that was more metaphorical. What about my problems?
I'm so sorry.
A what?
Yes, Justin was at my house and he saw my Lego Hogwarts house. I put it in my mom's office. I didn't know he was knocking it over. Yeah, I'm good. Where to start this? Are you giggling over there? Dear.
Why are they doing that in the middle of the day?
I've always wanted to ride on one of those. You can't tell me that.
Well, the problem with that is if you tried to ride on it immediately, there would be great disappointment. Because you'd be thinking, wow, this is not as exciting as I thought it was.
That's so true.
There they go again. Okay. Weirdness. She's just going back and forth.
That's so cute. The Oscar for a ride.
No.
Is anybody in here give me the permission to punch them in the face so I get offended?
So the problem is they would have given you permission to do so. So that would have been collusion. So you'd be getting that person in trouble too. Plus, I would have to actually report it. But if I just see it as like play acting, I'm just going to be like, meh.
Okay, then I punch you.
Okay. That would be expulsion.
What?
You physically assault a teacher?
Oh, why is it so hard? Why are you laughing?
I don't know. No reason.
You think it's funny?
I think a lot of things are funny. I think dogs with top hats are funny.
You think it's funny to watch me suffer?
Well, it's part of the reason why I get up in the morning. I only survive off the tears of students.
This is coming from the same person who built gingerbread houses with their families during Christmas time.
Hey, we won an award.
I know.
Yeah.
Trust me, I remember.
We're an award-winning gingerbread building family house. I don't know.
Let me guess, you like picket fence too.
I wish. You make it sound so easy. Yeah, I was born and raised in Barnegat. Oh,
You
goodness.
live close to your parents, you visit your grandparents sometimes.
Yeah, I live close to my parents because my parents are in their 80s.
Oh, people are so cute.
And I'm the youngest, and I took it upon myself to be closer to them just in case something happened.
You got stuff with them?
Yeah, I got stuck with them.
Like, I know you love them, but
This conversation's gone off the rails. Let's do these problems. Number 15. Number 15, I suggest strategy number 2. Simply because there are two fractions where both denominators are exactly the same. And because of that, it's fairly straightforward to multiply through by one thing to destroy all those fractions. If you multiply through the entire thing, I'll zoom in on this half of it, but if you multiply through that entire thing by g minus 2, in the first fraction, nothing cancels. In the second fraction, the g minus 2's cancel, leaving you with this. And in the third fraction, the g minus 2's cancel, leaving you with this 2. Using strategy number 2 is the absolute fastest way to get number 15 done. I still have to work towards getting the answer, and yes, it is still going to be a quadratic. I distribute this g. I combine like terms and subtract that 2. And I have my quadratic. Let me zoom out a little bit. There we go. So my quadratics are going to be incredibly helpful. If I were to factor that thing, I end up with g minus 2, g plus 1 equals 0. And I want you to notice something very important here once I get my answers. I get an answer of positive 2. I get an answer of negative 1. Look at the bottom of my screen and notice something. What have I not done with my answers?
you didn't circle them.
I didn't circle them yet. Do you know why? Well, I'm kind of done with like the vast majority of the work. I just have to use my brain for this last little bit. Watch very closely. Why? I circled one of the answers and I crossed out the other one. There's a very short explanation. Very short explanation. What would happen if I plug that 2 back into the problem? 0 in the denominator. That's the simple reason. That's the short reason. If I took that answer of 2 and plugged it back into the denominator, it would not work. The -1 does. That's my only answer to this problem. Which is nice. Oh, this problem. Let's try number 8. Number 8, I got you started by telling you to multiply that middle fraction by 2 over 2. It allows me to combine those two fractions into a single fraction where it ends up being 1 plus 2 times 5, which is 11. In combining those two fractions, I get a single fraction equal to a single fraction, which allows me to butterfly. People are, I don't want to say they're more comfortable with it, but people tend to like the butterfly method because of their past history with it.
I just feel like that's such a common thing.
Butterfly? Yeah, it can.
I'd much rather use method that's called the butterfly method rather than the demon destroyer 87, you know?
That's true. Why would it be 87?
I don't know, that's just a number I use for everything.
Okay.
It's how many people it kills.
Okay. Wow.
Okay.
Well, the thing is, no one ever believed you, though. When I do this butterfly method, I end up having to distribute this 11 to the h minus 1. So it ends up becoming 11h minus 11. But please note, there's no quadratic. And because there's no quadratic, I actually don't have to do any form of factoring. In fact, I'm just going to subtract 11h and divide by -5. And I end up with that fraction as my answer. It may seem strange, but that is literally what the answer is. That's all that you can do to the problem. After butterflying this problem, it just turns into a basic linear problem that you would have done in like pre-algebra. It's very strange. But again, these are these two strategies coming into play. One might be easier than the other, depending on what the problem looks like. If you think you can destroy all the fractions in one fell swoop, go for it. If it looks easier to butterfly that thing, then do it. Now, I'm not going to do this problem again, but look at number 9 on your worksheet. Look at number 9 on your worksheet. It'll focus in a moment. Number 9 on that worksheet is automatically set up for you to butterfly this thing, which is really nice. You don't even have to worry about it. There's one more problem I want to do off this worksheet. One more problem before we get to the intervention period for today. Oh, absolutely. Which one? Number 8? I can zoom in a little. The bottom half? Gotcha. Yeah, those red lines didn't show up as much as I wish they would. They look pink from here. Do they look pink to you guys?
Yeah. They look like red color pencil.
No, I mean it is,
Oh.
but
They still look big, big? That's a good thing. I'm the second color.
okay. I got you. But there is one more problem that I want to do today. Last problem off of this worksheet. I want to do number 19. Now, I'm going to tell you something about number 19. It is not as bad as it looks. I don't think you were.
I was.
No.
If I wasn't, I'd tell you.
But what if that was a lie too?
Maybe it was. Guess you'll never know.
Number 19, the last problem that I want to do today is honestly not as bad as it looks. In fact, it's quite simple once you know the trick to get this thing done. I am going to employ strategy number 2 on this problem. Strategy number 2, where I destroy all my fractions in one fell swoop. The problem is that it looks like I have 3 completely different denominators. It looks like all 3 of my denominators are completely different, and that's going to make my life kind of not nice at the moment. But there is one thing that you can do that you can immediately turn this problem around. There's one thing that you can do to make this problem 1,000 times easier than the way that it looks at the moment. You can factor that quadratic. If you factor that quadratic on the right side of the problem as your first step, it makes solving this thing so much nicer. I wonder, 2 numbers that multiply to positive 12 and also add up to negative 7? I wonder. K minus 3, K minus 4. But do you know why that makes our lives so much easier? When we multiply through by the common denominator, what I'm going to multiply through by is K minus 3, K minus 4. If I multiply through by K minus 3, K minus 4, it's going to destroy all of my fractions. Now that I realize that those are what all the denominators have in common. But if I multiply through by K minus 3, K minus 4, watch what happens in this very next step. In the first fraction, the K minus 3 cancels out. But that K minus 4 is still there. In the middle fraction, the K minus 4 cancels, but that K minus 3 is still there. In the last fraction, they both cancel, leaving me with a 25. This problem turned from a nightmare into something that you would have legitimately seen in 7th grade. The only thing you had to do was realize you could factor that bottom right fraction. Recognize that the denominators do all have something in common. Multiply through by that common denominator to destroy all of the fractions in one fell swoop. And now all I have to do is this. I'm going to distribute these numbers I am going to combine like terms. I'm going to add the 24. And I'm going to divide by that 7. The idea is that if you factor, if you multiply to destroy all of those fractions, you turn a nightmare problem into something from pre-algebra. And the answer ends up being quite nice. You just have to remember to factor, if possible. A lot of these problems you can't factor. A lot of the problems that we did earlier today, number 15, number 8, number 2, number 9 even, you can't factor on any of them. But on number 19, you can. And when you do, those denominators match up in the most perfect way possible. Now, we will get more practice with solving these things on Monday. but I do have to transition to the intervention period. So if you would, if you do not already have them out in the classroom, you're going to need to break out those Chromebooks. Yeah. I think this water thing over here is already up to 700. Yeah. It was. I wish they installed them when they told us they were going to install them last fall. They're in the building. We just need to install them. Yeah, less than 2 months ago. Anyway, for those of you that are on the live stream and for those of you that are here, obviously you're logging onto those Chromebooks. You need to get to your Google Classroom stream. In a moment, I am going to make live the remediation enrichment for the day. I just need to attach the proper link, and then we can go from there. Now, you guys took the pre-test or the pre-assessment the other day. The pre-assessment for this one was, unfortunately, not as good as the first one. When I say not as good, I mean like the vast majority of you bombed out on this pre-assessment. But again, the pre-assessment, that, did not count against you. But this remediation obviously will eventually turn into a post-assessment. So what I'm going to do is I'm going to post for everyone the same assignment, the remediation assignment. And I would like for you to begin working on it. Now, I'll post it, and then I'll read the instructions. So let me assign this first. Click. And click. And it has been... Come on, thing. Work. Assigned. There it is. I was waiting for it to actually go through. It did. So I'm going to bring it up on the screen up here. Now, this remediation assignment, just so you can see my instructions up here, there is, that's not us, there is a Google Slides attached. Attached is the Google Slides assignment for this intervention period. Your task is to watch the videos in the Google Slides and begin working on the problems. There are actually 4 short videos in total for these slides. There's 2 of them on the first slide, and then there's 2 more in the slides afterwards. Since I want to make sure that you have enough time to get these done, you will be working on this for the 513 and 517 intervention periods. That is today, and that is Monday. So please do not feel like you have to rush through this and get it done today, because obviously you're going to be watching part of those videos, and some of those videos are about 3, 4, 5 minutes long. You can watch a couple of those videos today, work on some of those problems, and then save the remaining videos and problems for Monday. But even then, you're going to be working on it today and Monday. It won't be due until the beginning of the day. It will be first. I mistyped that. I'll have to redo that. But it will be due Monday. I'm sorry. It will be due Tuesday at 7:30 in the morning. I'm going to edit the instructions. The grammar's off right there. Edit. It will be due. Save. There it is. It was fixed. Let me go over here. Click. There we go. So for those of you in the live chat, obviously you're going to be working on this on your own, but I will keep the live stream open in case you have any questions. And of course, for those of you in the live chat, I see the comments that you've left so far. If you haven't left a comment, please make sure that you do so. But for those of you right here, you have the next 22 minutes to begin working through these remediation slides. Again, you have today and you have Monday. So please don't feel like you have to rush through it. Let's get to work. Probably. I think everyone has freckles to a certain point. It depends how much sun they get. No. All right. Like I said, we will continue with this on Monday during the intervention period. If you haven't left a comment in the chat, please make sure you do so. Bell's going to ring right there.